Welcome to the block revolution. Today we will build a Flutter dApp with VScode. You will learn how to install a personal Ethereum blockchain which you can use to run tests, execute commands and inspect state called Ganache. We will program a smart contract in Solidity using the Remix IDE. By the end of this video, you will have built a HelloUi.dart that is able to interact with the Ethereum blockchain. Let's get started. So let's start. I will assume that you already have Node.js installed. If you don't have Truffle, you can install it with this command. Next, choose the folder where you want to create your Flutter app and just create it with this command. We will call it Hello World. Now get into that folder, and in here we want to initialize Truffle inside the Flutter project directory with the following command. Override test. Now we will open VScode. Let's look at the directory structure. So in here, Truffle created for us this contracts folder that has inside this migrations file that will be created every time you use the command truffle in it. We have the migrations folder that is used for deployment and contains the migration scripts. We have this test folder that is only has this git keep, and we have this truffle-config that we will be changing in a minute. Let's go and create a contract, write it using Remix. So the Remix IDE allows developing, deploying and administering smart contracts for Ethereum-like blockchains. It is also very useful for learning purposes. Now we write the SPDX license identifier. This is a standard procedure. Then we need to declare the version that we are using, the Solidity version we will be using. Then let's create the contract. Inside we will have a public string variable named username, a constructor where we set username to subscriber for logical reasons, and let's create a function. Now first, we don't use public anymore in the constructor. That was used in previous versions. I added a function setName that receives a string memory name. The function is public, and the only thing it does is to assign this received value to the public variable username. And that's the only thing that the contract does. Let's compile. And we can test it here in Remix. We deploy it, here it is, down here. We can access the function in here, and we can get the value, the current value. So if I press the username button, I will get subscriber. Now let's set the name to my name, for example. If I fetch the name here, the username, it changes. Very nice. Now, what I want to do is to take this contract and let's create a file inside the contracts folder, hello world. Now we will paste the code in here, and we have this problem, requires different compiler version. This happens because we have to change our truffle-config file. First thing is getting rid of all these comments inside. I will uncomment this development part. So here it is. As you can see, the version that Truffle is using is 0.8.11. We can change that in here, and we already have no error. Let's just add this information also. Remix allows us to do everything in here. It has the whole environment in here, but when using VScode, we need something, a local blockchain that can help us create our contracts and test them in a safe way. So for that, we will be using Ganache. What is Ganache? Ganache is that personal Ethereum blockchain that you can use for testing purposes. It allows you to use a graphical user interface that you can download in here. So go to trufflesuite.com/Ganache and install this interface. And when you open Ganache, you can create a new workspace. And that is what I did. I called it Hello World, and then save it, and here it is. And what you have is some accounts that you can use to transfer if Okay, you have the address and you have the private keys. Of course, this was really if I wouldn't be showing you the private key. So this is for development purposes. Don't ever show your private keys to anyone. Inside the truffle-config, we are telling VScode where it has to connect to. So in here, we have this host, and as you can see, the information I get from Ganache is what I am placing inside here. The host, the port, and the network ID. When I migrate my contracts in here, I'm telling what is the path to my Solidity contracts, and below I'm telling it where I want to save my ABIs that are JSON files. I already have the contracts file. Create a new folder called assets/contracts ABIs, and in here will be the files that will allow me to interact with the blockchain. Now we will go to the migrations folder, and in here let's create two deploy contracts.js, and we had this information. So in here we are getting the hello world contract, and we are deploying it basically. We will open the terminal, and in here let's migrate the contract or our contracts. We can write truffle migrate, or if you already migrated, you can use truffle migrate -- reset. Let's use it, and now it should compile successfully. So here it is. In the hello world contract we have the blocks, and most importantly the contract address that is here. Because we are using test-driven development, let's create inside the test folder a new file called HelloWorld.js. So first we must know where the contract is located. We have this contract function, and inside it we will create one test. And this is the way we do it. We write it, and inside we describe what the test is doing. In this case, it should return the passed string. So the first thing we should do is to get an instance of the contract. Next, we pass a string as an argument to the set function, to the set name function. And now we need to see if the name variable changed. So remember that we created this string public username variable, and because the username variable has a public modifier in the smart contract, it automatically generates a getter for us, so we call it directly. Finally, we use an assert function because truffle imports chai, and we check if the name is set properly in this way. Let's run the test, open the terminal, and write the command truffle test. Our test is failing. Hello world name is not a function. So inside the test in here, this name that I'm using here is the getter, but if we go to the contract, that is wrong. It should be username. So let's change that, and now let's try the test again. Well, as you can see, the test is now passing. Great. Now the contract is working as it should, and we can start thinking in the way that we are going to build the front end. So here we have an image that shows the way that the app will look, the dApp will look. So this is a basic screen with a text field where you will input whatever you want, whatever name you want. You will set the name, and that name will appear here next to the hello word. Okay, so this is basically it. Now to make this dApp work, we'll need to add some dependencies. So now go to the pubspec.yml file. This usually has a lot of comments, and I will delete all of them. Here, below the dependencies, you'll have Flutter.env. This will be used to create a file where you can store your sensible information, where we will put the private key. Not that that is important in this case, but it is a good practice, so we will do it. We have Flutter Riverpod for state management, Flutter SVG for the background image, Google fonts for using that font that you see on the dApp. The Web3.dart library won't send signed transactions to miners itself. Instead, it relies on RPC client to do that. And for that, we are using this WebSocket, and you also have here the HTTP package. Now that we are here, we will also add the ABI that is located inside your assets, inside the folder contracts ABIs. You should have this hello world JSON that inside has this ABI, and in here it is this file that we will be using to interact with the blockchain. Again, in the pubspec.yaml file, go to the assets and add these three assets: the hello world JSON, the images folder that we will be using in the front end, and this .env. What is this? So in the root folder, I will create a new file, .env, and now let's go to Ganache, to the first account. We click on show keys. We will copy the key that refers to the first address, that is this one. We will paste it here and just create this Ganache private key. So after this relatively long process of setting up the dApp, let's now create the Dart file that will allow us the interaction between the front end and the blockchain. In the lib folder, we will create a new folder called Utils. Inside it, create a file Utils.dart. We create this Ethereum Utils that extends state notifier, and to use this we must import Flutter riverpod. Now it is asking us to create a constructor. The only thing we are managing here and that we are listening to is if we are loading something, some information or not. So when we call this class, it will make an initial setup. And what is that initial setup? We will instantiate the HTTP client and the ETH client, and we will connect via the WebSocket. We will get the ABI, the credentials, and the deployed contract. So let's do that. First, we need all these variables. The Web3 client connects to the Ethereum RPC via WebSocket. We have this bool is loading. To check the state of the contract, we have a string ABI, use it to read the contract ABI. This Ethereum contract address that will store the address of the deployed contract. Let's import here the dependencies. We will need the Web3.dart. We need some variable for the credentials of the smart contract deployer, the deployed contract, where the contract is declared for Web3.dart, and in here we have the functions that we will be using. This variable stores the set name function declared in the hello world contract, and this set name stores the set name function declared in the same contract. We also need this deployed name will hold the name from the smart contract. Now to get rid of this, we have to import the HTTP package as HTTP. Also we need the RPC URL. Let's import the WebSocket package and this RPC and WebSocket URL. Let's put them in here. So as you remember, this refers to the Ganache server. In here you get the private key from the .env file. One important thing that I almost forgot, you have to go to your git ignore if you are thinking of getting this to GitHub. You should have this on these files to make sure that this .env is not uploaded. So now let's import flutter.env, and now we need these three functions: get ABI, get credentials, and get deployed contract. Let's create them. So first, the get ABI. Let's get rid of these errors. Undefined root bundle. We need services. In here we need Dart convert. We are reading the contract ABI. In here we get the ABI from the JSON file in the assets folder, but what we really are interested in is that bit that is inside the ABI here. So this is what we are getting, what is inside the square brackets. Now we get the contract address from that. We get the credentials using the private key, and we are missing the get deployed contract. In here, we are telling Web3.Dart where our contract is. We are getting the username and the set name functions. When we initiate the contract, we also want to get the name that is stored. In this case, if it is the first time, what we will get, what we assign it to when we deploy the contract. In this case will be subscriber. Let's write this get name function. We get the current name declared in the smart contract. We are calling the function username with no parameters. And in here the deployed name, well, we are receiving a list, and to make sure we get what's inside it, in this case the first element or the only element we'll get, we can write it in this way, or first. Both should work. IsLoading is set to false because we already got the name, and as you have seen in here, when we access the Ethereum Utils, we are saying that it is loading, and when we get the name, we set the state to false. IsLoading is false and state is equal to IsLoading. Now we know how to get the name. The only thing we are missing is how to set the name, so we need another function. So here it is. We set the state to true. We are waiting for the transaction to be completed. We send the transaction. We call the contract with the function set name, and in here we pass the name to set, and after that we get the name again, and after we get the name we will set the state to false. So we will have the front end listening to all of this and updating accordingly. Notice that this dApp is developed for working with Ganache for different test networks like Rinkeby or Robston. We should probably handle this in a different way, but for the simplicity of this app, this will work. This is what we need for the front end to interact with the blockchain. And what we are missing at this point is only the front end. Inside this main file, I will delete all these comments and make some small changes to the first widget that we get in here. I will delete this my home page completely, all these comments. And in here, home will be Hello UI. And the title is Hello World. I will delete this theme also, get rid of the banner that usually appears on the top right corner. Now, we don't have this HelloUi because we are using the .env file. We have to add this line to the main function and also make it asynchronous. Import .env. And for RiverPod, we also have to add the provider scope so we can have access to the information we want to share across the app globally. So in the lib folder, I will add the UI folder. Inside this, create HelloUi.dart, and let's make it a stateful widget. Go back to our main and import it. Now we import the HelloUi.dart. Let's make this const so that VScode doesn't complain. And now let's launch the app. So here we have it. As you can see, it's amazing. Now take a look at the image again. We have a background image. We have this little text that says hello subscriber. We have the text field and the button that will set the name after we type it. So I added this scaffold with an up bar and the text hello world with this font size, and the color is white. This is fine, but it is not the type of font we want to use. As you can see in the image, that's not the kind of font I want to use. So let's do this. We will add the root folder. Let's add Google Fonts just to create our custom text, and inside it we will add these two TTF files. So you can go to the fonts.google.com and search for dancing script, download the family, and you can extract the file and add it to your Google Fonts folder. Okay, then you are good to go. That's all we need to make this work. We have this text, but I want to create a text widget that I can reuse because we will be using this font more than once. So I will be creating a new widget, so a new file called, and inside it we create a stateless widget called custom text, and it returns a text widget that will receive a text, the font size and the color that we are using inside this text widget. So in here we are then using the Google Fonts and we will be using the dancing script. I don't even know if we are using OpenSens, that's no problem. So we set the color that we receive, the font size, the font weight, we put in some shadow, and this is it. Now back to the HelloUi.dart. Let's make the change. We are using the custom text. Let's import it. Let's enter the title, and here it is, the new font. We can make it a bit bigger. Now let's create the body of the scaffold. Now we add a container because I want this background with a gradient. We have to add a box decoration with a linear gradient for what will be coming as a child. And that is a stack. Why a stack? Because we need a background image. And we will put the image below and all the text and the text field and the buttons above that. Here we have a stack with the children. The children that will be below is this HelloImage.png that doesn't exist. So I'll go to the assets folder, images, and I will place the image inside. Now I'll go to the terminal just to make sure everything works and run Flutter pub-get. I had to restart the emulator to see the changes reflected. We have this text in here, the not dynamic. It's because where we have this text, we will be receiving the string from the blockchain, let's say, using the provider through Riverpod. Also, when we get the keyboard popping up, I want to make this image 50% opaque. This will be also dynamic. Now let's create the most complex part of this, that is the text field. Now I added the text field with input decoration, all these little visual characteristics. The button, that is pretty simple. We have a padding, an elevated button with the set name text. We will be doing something inside this onPressed function, but before that let me show you something. Now we have this text field, and the only way we have to dismiss it is by pressing this check button inside the keyboard. But I want to do something different with it. I want it to go away if I tap outside the text field. You see this a lot in apps. So let's implement that. The way to do it is to wrap the scaffold widget with a gesture detector, and we have the onTap function, and inside here we will have this focus scope of context and focus. This means that when we tap on the text field, it will pop up the keyboard, but if we tap outside it, it will unfocus and the keyboard will go away. So this is nice. Now we need the focus information in here on the text field, and also this controller, and this is what will give us the value that we write in here and that we will be passing to the utils so that we can interact with the blockchain. So I will uncomment this now, and up here I create a text editing controller and the focus node. Also, we want to listen to the focus. That means that we want to listen when we are using the text field, so we can change the opacity of the background image. We do that with the listener, and also we have to dispose it. And this on-focus change is what will be controlling the opacity of the image. Now up here I want to create this provider that will give us the value of the opacity. So here we have it. It is a state. I'm using a state provider, and to be able to access the reference to the provider, we have to make the stateful widget a consumer stateful widget, and that implies two changes, one in here and the other below. And that's it. Flutter river pod imported, and now it should work. Now we have this error because those values are not constant, so let's remove const from here and add it here. Now what we are missing to have the app ready is we have to rebuild when there are some changes, and for that, inside the build method, we have to listen to the utils provider. Do we have it? No. So let's go to the utils, and up here let's add this state notifier provider that will give us access to the Ethereum Utils class, and to specifically if we want to the state to know if it is loading or not. Now we can import it. Because we are working with the image opacity, we have to listen to that also. We have to be aware of the changes. So in here, we are watching the image opacity. One thing, when we unfocus, if we want to change the opacity, we have to come here and change the state. Probably not the best option, but it will work. So we change it here and also add it here. And what we are doing, if the name controller text is empty, we return with nothing. If not, we change the state of the opacity and we clear the name controller. And we have to go to the opacity, and in here change this to image opacity, that is, and we will set it to the value that we are receiving in here. So this is the effect. As you can see, it works. It gets the job done. Now, the only part that's missing is really the name making the changes on the blockchain. And this is what it's all about, isn't it? So let's do the last part. What we want to do now is to come here inside the set name button, and if we have nothing too rigorous about the rules of the text field, it is not empty, will work, okay? In here, we will use the value from the name controller, and we will set the name on the blockchain, on our personal blockchain using Ganache. Let's see. Before that, we have to come here, and then the not dynamic, if you remember in here, we will just remove this and use whatever we get from the utils. We have to remove the const keyword in here. We will make this first widget constant, and this one won't be constant because it is changing in here. One last thing that is very important. So we are showing this stack, this image in here, but if the utils is loading, we don't want to show this. We want to show some sort of progress indicator, and for that we will check if it is loading, and if it is, we will show a circular progress indicator. And if it is not loading, we will show the stack. Now let's try it out. We have to use a key here, a center widget, child, and now let's go down here. Okay, let's try it. So it is not working as expected because I have to click the emulator to see the response. And to avoid this, I will probably watch the utils provider, and as soon as I get the result, it should rebuild the widget. Okay, that's it. Okay, it is done. I hope you enjoyed it. Let me know in the comments if you like this approach of the full stack. If you want to try it out yourself, check the link in the description, where you can access all the code as well as a tutorial that I included in the README file of the repository. This is a pretty basic dApp, I know, but it is complete. There is a full project from backend to front end. We've done everything. I hope you enjoyed it, and make sure you like and subscribe so you can be notified when I upload the next video. Thanks for watching.